All right, we're going to take a real quick look at today's notes, and this is really going to focus on calculator use. So I'm going to show you how to do this with the TI-83, 84. If you have a scientific calculator, there is a brief description here, but again, I'm going to focus on the required calculator for the course. The biggest thing that I can say is you want to make sure that for this class you get it into degree mode. All right, so on the TI-84, to do that, first thing you're going to do is you're going to hit mode up here at the top. All right, and then you're going to go down to, it's about the fourth line down, all right, where there's radian or degree. So we're going to shift to the right, we're going to hit enter, and now it's in degree mode. All right, so that's going to be the first thing we want to do because the angles they're going to give us in here are going to be in degree mode. All right, now, the other thing that we're going to do is, for the most part, we're going to take the answers today to 4 decimal places. All right, so I'm going to go ahead and quit out. So second mode, that'll quit out of that section once I've set it at degrees. All right, and this is asking me to evaluate a couple of these. Now, we're not going to do all of them. I'll do the first 3. You can do the second 3 on your own, and there's answers at the bottom so you can check yourself. All right, so for the first one, it's sine of 58. So I'm going to hit sine. I'm going to type in 58. I don't need any degree marker on it for the calculator because I've already told the calculator I'm in degrees. I'll hit enter, and I get a 0.8480. All right, and notice that checks with our answer down here. All right, now each of the trig functions works very similar. And again, remember, these are the ratios. So in a triangle with 58-degree angle, sine is opposite and hypotenuse. So we have x over y. So the ratio of that side, the x side over the y side, is going to be 0.8480 as long as that angle is 58 degrees. Now, we can do this the rest of the way through. So for cosine, we'll just choose cosine instead. This time it's 13 degrees, so we'll put that in. And we get a 0.9744. All right, and again, we round up because that 7, the next digit, is above 5. Then we can go to tangent, so tan of 34, and that gives us a point, so 0.6745. All right, so that gives you just a quick, how to enter that on the calculator. Now, if we roll to the next page, occasionally we're going to be looking for the angle instead of the ratio. All right, so the first 3 we did back here, these gave us the ratio. All right. The next ones, instead of looking for the ratio, we're going to actually look for the angle. So we're going to use the inverse trig function. All right, now this is easy enough to do on the calculator. If you're on a scientific, all right, you're going to follow that. But if you're using the required calculator, the TI-84, then we can go ahead and we can follow what I'm going to show you in this video. All right, so if we're trying to solve this expression for a, all right, the process we're going to do is we want to take sine inverse of the 0.4836, and that's going to give me the size of a. Now, to do that on the calculator, we're going to go second sine, all right, and we're going to type in our 0.4836. We're going to close that off, hit enter, and it tells us that we've got 28.9. Now, they asked me to the nearest degree. So I'm going to go ahead and I'm going to go with the 29 degrees. All right, so if I slide over to the next one, we've got cosine of b equals 0.5836. So I'm going to go to cosine inverse of 0.5836, and that's going to equal the b. So we'll go second cosine 0.5836. Close off our parenthesis, hit enter, and it's 54.2, so we're at 54 degrees. All right, now that same process is going to work throughout these, so I'm going to pick one that's a little harder to enter. So we'll go with this one right here. All right, so that's cosine inverse of root 2 over 4, right, equals e. So second cosine, and we want to get root 2, so second x squared, which is the square root sign, of 2. Then we want to move outside of the square root and divide by 4. So make sure you hit that right arrow key so that you get out from underneath the square root. All right, divide by 4, and then we enter, and we get 69.2, so that one would be 69 degrees. All right, now you can try the others on these first 2 pages and make sure they match with the answers down here at the bottom. And that'll give you a quick summary of how to do the calculator work that we're going to use when we get to the next problems. All right, and the next problems are really the heart of the section. We're going to either be solving for a side or we're going to be solving for an angle. All right, so on this one, the variable's on a side, so we're going to be using one of the three regular trig functions. If we were solving for an angle, we'd be using one of the three inverse trig functions. All right, so first thing I'm going to look at is I got this 28-degree angle. A variable's on opposite, and we know hypotenuse. So I think through my SO, CA, TOA. All right, and we said opposite and hypotenuse, so that means I'm in the sine. All right, and I know that sine of an angle, sine of 28, equals the opposite over the hypotenuse. All right, so the first thing I do is I identify what trig ratio, then I set up my equation. All right, so we identify sine theta, and then we set up the ratio. Now, from here we want to solve this algebraically. And we're going to solve this before we compute what sine 28 is. So I'm going to multiply both sides by 45.1. So I'm at 45.1 sine 28 equals x. All right. At this point, we can go to the calculator. All right. We don't ever want to go to the calculator too soon because what you're going to have is a lot of round-off error. And if your answers don't match to the number of places they're asking for, then you're going to end up losing points. So you don't need to lose. If you just wait, get to an exact answer like this, right, then go to the calculator and we'll type in 45.1 times sine of 28. We'll close that off, hit enter, and it tells me that x equals 21 point. Now, said use significant figures. So when I look at this, all right, I had a side with 1 decimal place. That was the least accurate side I had, so I'm going to give 1 decimal place my answer. So I'm going to say at 21.2. All right, 21.2 for my side length. All right, and this is really the heart of the benefit of trig. Notice how we took a right triangle, we knew one side, and we solved for the other. Now I could lean on Pythagorean theorem, or I could lean on a different trig ratio to find that last side if I needed to. All right, so that's really the heart of solving for a side. Now, if I roll to the next one, all right, this one looks like a similar setup. All right, so I look what I have. I have a 76-degree angle. I have opposite and adjacent. All right, so the 28.45 is opposite, the x is adjacent. So I think of my SO, CA, TOA. All right, and tangent, TOA, opposite over adjacent. So I'm going to say tan of 76 equals opposite 28.45 over adjacent x. All right, and that's our initial setup. Now, this is the type that everybody always makes a mistake on, where the x is in the denominator. So what we need to do is we need to be really careful when we solve these. So first thing I'm going to do is I'm going to get the x out of the denominator by multiplying both sides by x. So I have x tan 76 equals 28.45. All right, now I'm going to divide both sides, all right, by the tan 76, all right, to isolate the x. So now x is by itself, and I have 28.45 divided by tan 76. All right, so now I go to the calculator, and I got 28.45 divided by tan 76, and I hit enter, and I've got that x is 7 point. Then I look back. My least accurate side is 2 decimal places, so that's what I'm going to use in my answer. So 7.09. All right, so those are the two things that can happen when you're solving for a side. All right, the variable can be in the numerator like the first one, so in the top of the fraction. Then we just multiply the bottom over to the other side. All right, or it can be in the denominator. And when it's in the denominator, we've got to multiply it over to the other side to get it in the top, and then divide whatever's over there with the x to get the x by itself. All right, now the last one here that we're going to go through together, all right, this one is solving for an angle instead. All right, it said given two sides, find the measure of angle A. So I'm still going to start the same way. I'm going to identify the trig function. So on this one I have adjacent and hypotenuse. All right, so if I have so, ka, toa. All right, my adjacent is the 19.6. My hypotenuse is the 23, so I'm at cosine. All right, so cosine of A equals, and it's adjacent over hypotenuse, so 19.6 over 23.4. All right, so now I'm going to use the inverse trig, like that second calculator skill that we had. So A equals cosine inverse of 19.6 over 23.4. All right, and this is where I lean on the calculator. So we're going to go ahead and we're going to say second cosine for cosine inverse, 19.6 divided by 23.4. And when I hit enter, it tells me 33.11. Now, with degrees, we're going to always go to the nearest degree for the angle, right? And again, that's the choice that the team made. I would probably follow the significant digits if it was me, but they've chosen to go nearest degree on the angles. So we're going to go with nearest degree when we do that. All right, so that takes us through. Now, the next page is just 4 practice problems, so I want you to give those a try. And the answers are down there at the bottom for you so that you can kind of check. But again, it follows the exact same strategy as we looked at on the example problems we did, those last 3 problems, and the calculator skills like the first 2 pages. All right, so that takes us through today. Hope that helps. Bring your questions tomorrow. Thanks, bye.